Now the time has come to split our dataset into a training set and a test set, because the only way to know how well our model will generalize to new cases is to try it out on new cases. And we're going to train our machine learning model using the training set, and then we test the ability of our model to generalize and to forecast house prices for data points that our model has not seen before. So still we have saved our features in the variable features. And it's common to use 80% of the data for training and to hold out 20% for testing, but this depends on the size of the data set. So if we have millions of data points, it might be enough to have a test set of 1 or 2%. In our case, we have over 20,000 observations, and here it makes sense to have a test size of 20%. And now the easiest way to split our dataset is by drawing a random sample, and Pandas has a method for it, the sample method. And actually here we can define the fraction, and actually we want to sample 20%, so that's the test set. And then we can also define a so-called random state, and here we can pass any number, and as long as you use the very same number, then we get the very same sample. So to say, this is pseudo-random sampling that ensures reproducibility. And now let's create the test set, or more accurate, the features of the test set. So X stands for the features and Y for the label. And we save it in the variable capital X test. And let's have a look here. So these are actually here the random rows. And in total we have 4,087, and this is exactly 20% of, let's have a look here, of 20,433. Now there's one drawback of a simple random sampling, the risk of introducing a so-called sampling bias, and that means that the sample is not representative of the whole data set. And we have seen before that the median income is probably the most important feature. So having all low-income districts in the training set and all high-income districts in the test set wouldn't be representative, and this could lead to a poor model. And therefore, we should make sure that the 5 income categories in a training set and test set have the same ratios as in the whole data set. And this is also called the stratified sampling, and actually scikit-learn has a workflow for it. But maybe our simple random sampling with the pandas is good enough. And the rule is that the larger the dataset, the more simple random sampling approaches stratified sampling. And in our case, we should definitely double check whether we are close to perfectly stratified samples or not. And therefore, we can compare the relative frequencies of the income categories in our test set. First of all, so we pass true to the normalized parameter, and here we get 25%, 25, 25, 20, and 5. And this is actually equal, or at least very close to the ratios in the whole data set. So this is the whole data set. And therefore, we could conclude that in our case, with over 20,000 observations, so we can simply use here the random sampling with pandas. That's okay. Now we have created the test set for the features, and we can also get here the row labels for the test set. And now let's create the training set. So we check for each and every row label in features whether the row label is already in the test set. And if the row label is not in the test set, so this is the tilde symbol here for not, then it is in our training set, and we create the new data frame x train. And in total we have 16,346 rows or observations. And actually, for the sake of completeness, we can also check here with the value counts for the training set if the ratios actually are okay, and this is the case here. Finally, let's come to a workflow that is actually not necessary for our case, but for some more advanced workflows that are beyond the scope of this course, we should definitely work with a shuffled training set. So that means that the rows here in the training set are randomly ordered. And we can see here that the order is still the same as before. So we have still the original order. And now we can simply shuffle the training set by again using the sample method. And now we take the fraction one. So we are drawing all rows, but in a random order. And we override xtrain. And now the order is actually random. Next, it's time to drop the categorical feature income categories. So that's the feature that we actually do not require for our model and that we do not use. So we drop income category from xtrain and xtest. And now we have the final features for the training set and the test set. And now we have to split also the labels into a training set and test set. So we have still saved the label. So that's the median house prices. And we have to use actually the row indexes for the training set and the test set and filter label correspondingly. And let's make a cross check for the training set. So here in total we have 16,346 rows for the training set. And actually it starts with the row label 9,896. And let's double check here. And this corresponds to actually the features. Alright, thanks for watching and see you also in the next lecture. Bye.